Hey everyone, this is FRQ packet number 6, our last one. Yay! First I'll go over the trends as always. This one I left for the end because it does require a lot of thought. Okay, it's not necessarily difficult. Just like all the other packets, there are easy pockets of simple points that you can earn. Okay, and then there are some that are a little bit more challenging. Okay, so just keep that in mind. But as always, you shoot for the easy ones first, and then you work towards the other ones that take a little bit more time. Okay. All right, so here we go. Grab your highlighters. There's I counted 4 in this packet, but this one here is basically your graph analysis. This is where you start talking about F prime, F double prime. You talk about concavity, extremas. You talk about points of inflection, stuff like that. So we'll review in the next video, but right now we're just highlighting, okay? So the first one, very common. So I'll get that out of the way because I want to make sure that you guys get this point. Equation of a tangent line. Okay, you guys have seen this, and I want to bring it back up to you because it's not super common, but common enough to want to address. Okay, the equation of a tangent line. Here we go. So it first appears in 2009, Form B right here. Write an equation for the line tangent. Okay, 2008, write an equation of a line tangent. And if I miss it, I apologize. Right here, 2004, the tail end of part C. 2003, part C. Part C here in 2010. And I'll highlight this as well because it deals with the tangent line. I think the first one also deals with the tangent line, so I'll highlight that too. In 2006, part C. So quite a bit, not every single part, but for the most part. So notice how there was a calculator with calculator section, and the one prior to it is the non-calculator. There's obviously more non-calculators than there is calculator. You know, you guys have 6 FRQs. I would bet that this question will be one of the 4 non-calculator active questions. It's rare to see it in the calculator portion because usually they'll save that for accumulation or particle motion or even Riemann sums, right? So again, this is just based on what we've seen in the past 25 years, all right? Okay, here's the next highlight. Grab your next one. This one is, I'm going to call it evaluating. Okay, it's very straightforward. It's written a little bit differently each time, but let me show you what I mean by evaluating. It's when they're asking you for a value of some sort. So, for instance, in 2011 here, they ask you to find g of -3 and g prime of -3. Stuff like that we're going to highlight. Right here in part C, determine the function f. So finding the function, we'll include that as well. 2009, part B, find f of -4 and find f of 4. Uh, 2009, I'm going to go ahead and highlight this one here. It's because they're asking if the second derivative is positive, negative, or 0, so we have to evaluate it. 2008, 8. There's a little bit of evaluating right here with the limit. Although some can see that as an outlier, but it really doesn't matter. Okay, 2008. I don't think I see it here. 2007. I don't see it here either. 2004. I don't think I see it there either. 2004 Part B. 2003 right here in Part D. Find f of -3 and f of 4. 2000, I don't see any. 2007, they ask you to find the first and the second derivative. Want to say that's, yeah, that's it. Okay. And I'm going in the order of easiest points to probably most challenging points. Okay. By challenging, I just mean time consuming. Let's keep going. Let's do purple here. All right, the next one, the next two, well, let's just talk about it, okay? Something in regards to the second derivative. So concavity or points of inflection. Now, I know it's been a while since you guys have seen that, but I'll review in the next video, okay? So anything in regards to concavity or points of inflection. So for instance, 2011, the first one in part C, find all values of x where g has a point of inflection. 2011 form B, they're talking about concavity in part B. And you learn to skim through it, okay? 2009, find all values of x at which the graph of f has a point of inflection. So although there's a lot of verbiage, right, there's a lot of wording that goes on here, you'll learn to look at what matters, really. You'll learn to read kind of between the lines. We don't have it here in 2000B. 2008, we have something in regards to a point of inflection. 2008 form B, points of inflection. I think that's it. We have another point of inflection in 2007. We have something in regards to concavity here, but I'll highlight the whole thing. In 2005, the tail end of part D, find all values where the graph of G has a point of inflection. So this one pops up a lot, right? Here's part A. So you can see that this is probably something that you want to definitely conquer, right? It's here, it's written a little bit differently, but if you guys remember, when a function is concave down, the second derivative is negative, which is really what they're talking about right there. But don't worry, we'll review. Something in regards to a point of inflection in part C here in 2007. And in part B here in 2010, concavity. Here's another concavity question. And that's it. I want to say it popped up in every single section. Okay, maybe not all, but almost all. Okay? All right, here's the last one. The last one is reoccurring. Let's use yellow. And again, this one here takes up a lot of time, but not necessarily difficult, okay? You guys have seen it at least twice already. These are dealing with extremas, okay? So basically your maxes and your mins, whether it's local or absolute, okay? I would say that this type of extrema problem is relatively easier than the other that you've seen in accumulation and particle motion. Okay? All right, here's the last highlight, extremis. Anything in regards to a max or a min, or an absolute, or a global, or local, or relative. Here we go. 2011, part B, absolute max. Relative max, relative min in 2011B. Absolute max in 2009. Local max in part B. Relative min, relative max. Absolute max in 2008. 2007, relative max there. Absolute minimum in part D. 2005, relative extremum. That's just plural for multiple extremas. Determine whether it has a relative max min at these values, okay? In part C, determine whether G has a relative max or min at these values. I should highlight that first part too. Okay, absolute max in 2004. 2003, I could highlight the first one, but I'll just leave that there for you guys. They're all closely related, so it's kind of tough to not want to highlight all of them. 2000, there's a relative min, a relative max, and an absolute max, okay? Something in regards to a relative min and a relative max there. And the very last one, 2006, has an absolute max, okay? Not a lot of outliers. Not a lot of questions that were left unhighlighted. But again, like this one, 2003, where F is increasing, that's closely related to graph analysis, okay? Some other ones that you want to note, like you tend to see average rate of change, I want to say twice or three times throughout this whole packet. Average rate of change you guys have seen in a previous packet. So what's an outlier here is definitely a trend in another video. Okay, so definitely do those. Here's another one regarding the mean value theorem, which I discussed in a separate video there, how to attack those. Here's another average rate of change in 2009. Okay, but definitely attempt to even do the outliers, okay? Don't just do the highlighted ones, but definitely focus on those first, all right? Okay, so in the next video, I'll be covering these four. Go at your own pace. Pause the video whenever you guys need to, and text me if you need clarification, okay?